Okay. So we can do something simple called elevator problem. We'll do some one dimension, then I'll go to the two dimension. So now in elevator problem, let's say we have an elevator which may be accelerating up, going down, or maybe moving up with some velocity also. So anything is possible. So we'll take up the case when the elevator is accelerating up. Okay. So let's call A as the acceleration, and this is your ball which you're throwing, and you're throwing the ball with some velocity with respect to elevator. So I will just name something like okay. So let V not be the velocity of ball with respect to elevator. So now elevator may have some velocities, which is not given, but it doesn't matter actually. But because you want to solve this question, so you can assume that let's say the at the time of projection, okay. So let's say V not be the velocity of ball with respect to elevator, and V be the not know, something different similar. VE be the velocity of elevator with respect to ground. That is the actual velocity. So at the time of projection, the elevator is already moving with what velocity? It is moving with velocity
V
VE.
naught.
VE elevator. V naught is the velocity with respect to elevator. Now you need to understand this concept. So V naught is not the velocity in the ground frame. So what is
Yes,
the
sir.
velocity? What is the velocity in the ground frame? It is the sum of the two. So velocity of ball with respect to elevator, you can address Vp minus Ve. Now, velocity of ball with respect to elevator is given as V naught. Velocity of ball is unknown, and the elevator is also upward V. So the Vb turns out to be V naught plus V, which is obvious. Like we could have said this like common sense. So the Vb is representing the velocity of the ball in the ground frame, and V naught is representing the velocity of the ball in the elevator frame. Now these things are very important to understand, analyze, and being able to write it down. Okay, so the first question is calculation of time of flight. Now there are two ways to solve this question. One is of course the ground frame. Okay, another is the relative frame. So for an observer who is inside this elevator, let's say the watchman who visits. So for this fellow, he is observing the elevator. Sorry, the ball. So for this fellow, what is the velocity of the ball with which it is projected? The answer is only V naught. Why? Because he cannot see VE. V is same for ball and for the security person sitting in the elevator. So for him, the ball will go up, and will just come down. Now the question is, what is the acceleration of the ball as seen by this observer? So is it G?
Sir, minus G minus A.
Yeah, so it is total acceleration is G plus A downward for this observer, you can say. Okay. And therefore, the only difference that we can do is replacing G by G plus A, and the answer is same. So we know how to find the time of flight. So the time of flight in elevator frame is very easy to find. And it's only one line answer. It's a 2V naught by G plus A, just like the formula which we have. So we can call this as G effective, like some net value. So the formula remains the same, 2U by G effective. And now that's very easy. Like you can understand that how quickly we were able to find the answer without worrying about the velocity of elevator. Now you may ask that why the velocity of elevator is not affecting the answer, because the velocity of the elevator is actually inbuilt to the velocity of ball in the ground frame. So let me show you how to solve the ground frame. The ground.
Sir,
Yes.
so how that can G plus A?
Okay. So for that, you can say acceleration of ball with respect to elevator. What we can write? A acceleration of ball minus acceleration of elevator. Okay.
Yes.
Now acceleration of ball with respect to elevator we are looking for, but we know the two values. So what is the acceleration of ball? Minus G. And what is the acceleration of elevator? Plus A. So it turns out to be minus G plus A, which means it's second downward. Okay, I'm not using the J cap notation. So the acceleration of ball with respect to elevator is this much. That is what I have shown here. So this is going to be A, B, E, because who is solving this problem? Observer in the elevator. So every value we must write in the frame of observer, isn't it?
Yes. Sir,
Yes.
Sir, T is equal to 2B naught by G plus A. That sir, in the G plus A we have written G. What is that EFT?
That's G effective, EFF. GF means G effective, like the net G that the observer in the elevator will experience. So for this observer, the ball is coming down with what acceleration? So for this observer, it is not free falling. It is free falling with greater acceleration, G plus A. Is this clear? No. Yes.
Clear, sir.
Okay. Now imagine the situation like how some would will solve in the ground floor. Look at the scenario. You're throwing a ball here with initial velocity. And elevator is going up with acceleration A, and the velocity of elevator at this instant is V. Okay. Now the ball will go up and so the elevator. So when the ball will go down, it will not hit actually there, it will hit somewhere here. So that is the ground frame scenario. Now that's scenario difficult to observe. So what is happening is, let's say at t equals to 0 you're throwing and it is hitting back the floor at t equals to t, because that is my time of flight. So what we can write about how we can solve this problem? So it's very easy. If I choose this as origin, if I choose the initial position as origin and up as the y-axis, one thing is clear that this floor of the elevator and the ball will have same y coordinate finally. So initial, you can see that initially both the floor of the elevator and the ball are at the same height, and they're also same height finally. Okay, so if I say this as origin, so we can say that y of ball must be same as y of elevator. That's simple. And what we can write the equation for ball which is thrown vertically. So what is the velocity of ball in the ground frame? You can see here.
VB equals to V or not plus one.
So you can write as, first of all, you write as VB T minus half GT square Y, because the ball is in free fall. Now elevator is accelerating upward. So the velocity of elevator in the initial velocity VBT plus half the Y plus A, because it is accelerating upward only. So that's plus A. But the ball is free falling, so it's a retarding actually. So we have this expression. And what is VB exactly? So VB itself is VO plus VE.
So at last you have to find the acceleration only.
Pardon?
So means in this problem we have to find the acceleration.
Time of flight. So you can see clearly that the VET will cancel out from both sides. So it really doesn't matter what was the initial velocity of the elevator taken into consideration. And if you just rearrange and solve, you'll get answers to V naught by G plus. So this is how we solve in the ground frame. But you can see that it's a really faster to solve in the elevator frame, because Once you know what is the acceleration of the ball in the elevator frame, once you know what is the initial velocity of projection in that frame, so we can use the concept of vertical motion to directly get the answer. Or because it is leaving the floor and coming back to the same floor as per this observer, so the y displacement, so y of ball with elevator is 0 and y of ball with elevator beginning is also 0. So you can use the definition, basically what from where we get the be is 0. So you can add the formula of relative kinematics and you get this answer. So to solve every question, you need to find the VBE and AB. You can see here we are taking this AB, and why we are taking these two values, because we want to solve in the uh, which frame, the elevator frame or the relative frame. So, but if you want to solve in the ground frame, you have a better method, as you can see on the right hand side. So using this method, you can solve all this. Okay, so do one practice to get the hang of this method. So I am taking the same example with one small change, that I am throwing the ball up. You're throwing again the ball up.
Sir, if the lift is going down, then
Yeah. So you're throwing the ball up. Now what is happening is the lift is now accelerating downward. And at the time of projection, the velocity of the elevator is also downward. So this will act as the initial velocity for the elevator. And this is the acceleration of elevator all the time. So you can just say A, or A equals to A. So now the question is find the time of flight. How much time it would take?
sir, can
And
we try?
again, yeah, so velocity V naught is again representing the same. So VBE is V naught. So you can say J cap. If you're confused with the direction, just use J cap to get the right answer. Okay, go ahead.
Sir, it's 2 V naught by A minus
Mhm.
G.
No, it's not A minus G. It is G minus, because the net acceleration is downward, right? So what is the
Yes.
downward value? Okay. Okay. So it's good
Sir,
to
I'm
say that it's
solving, sir. So 2 minutes. So the acceleration will be A minus,
the acceleration A minus G is which direction, upward or downward?
downward direction.
A minus G is downward.
Yeah, sure.
How?
sorry, upward, sir. I got A B E equals to A minus G.
Yeah, but that is upward.
Yeah, sir, upward.
So we want the axis on downward, right? You write in terms of A cap, J cap, not to confuse. You are getting confused. So you write in terms of J cap. So what we can write here? A B E vector equals to A B vector minus A E vector. Now what is the acceleration of ball? Okay, this we are finding. So what is the acceleration of ball?
minus
Minus G. And what is the acceleration of elevator? Minus K.
minus A.
So what we're getting is minus G plus G minus. So I'm taking minus common. Why minus common? Because I am looking for the downward acceleration. So this is the answer. Now if you say that, so do we need to solve like this way? No, no need to solve. So you can write the delta y relative equals to u relative in the vertical axis, of course. Uy relative into t plus half a over it into t. So you can just write like this without thinking much. And we know that because in the elevator frame it's going up and coming down, so this is always zero. And what is uy relative? It's v naught. And what is ay relative? So whatever it is, just write whatever it is. So it's minus that's it. And then solve. No need to worry the plus or minus sign. Because this entire expression will take care of the all sign. So because we are writing BE, B, so it means we are maintaining the order. We are not writing EB and B. So okay. So if you so it is up to you to apply the relative kinematics. Like it needs some time. It takes some time to actually hone this skill. It's not so easy, definitely. It will take some time.
Sir, can you show the last?
So why we took
I
delta y equals to 0? It's moving downwards.
Of course, no delta y of ball with respect to elevator.
Yeah, sir.
That is always zero, isn't it? So what we are writing is the VBE expression. We are writing this expression. So okay, once again, let delta y ball with respect to elevator is u ball respected to e plus half a b e t square. That's it. It's so simple. And we know that in the elevator frame, the ball has come down to the same level, so it's zero. You can think this as the origin in the elevator frame, right? You can draw a coordinate axis of your choice in the elevator frame, and UBE, basically that's VBE, so it's coming V naught by definition, and T is T, half is half. What is AB? So what you're getting? You're getting A minus G, right? That's okay. Okay. You're getting A minus G. So just substitute A minus G, and then rearrange. So once you do it, you will get the answer. G minus. So if you take the other side, it becomes negative. So no matter how you think, it is always the same answer. But oh yeah, I can understand. It's difficult in the beginning. Now, the easier one is like, can you show me the ground frame? Because in ground frame, it is always because it's going down. You can take the downward as positive y-axis. So you know that y of ball is y of elevator. At the time, it will hit back the floor, and it is leaving the floor also at the same location. I mean the same vertical height. So it's good to take the vertically downward as the y-axis and then solve the problem of like this. So can you try this problem in the ground frame?
Yes. Sir, I thought the answer. He's on ground floor.
So in ground frame, the answer is matching.
Yes, sir. Same answer. 2 V
Very
naught
good.
by G minus N.
Correct. So now you can see that relative motion is just additional idea. Like if you can solve question in ground frame, then of course you can solve the relative frame also. And it is not something like which is the only way to go ahead. So we could always solve question in ground frame, but the only idea is it is more you can say rigorous when it comes to ground frame, and in many cases it is really easy in the relative frame. But it's not easy to become master in one day. So you have to wait for your one fine day when you will actually realize how to do it. So it is the most difficult part of kinematics. Like most of the students do not feel very comfortable in the beginning. So mostly once you repeat the same chapter after a while, maybe when you are revising for the second time, it just might click. But if you practice enough, then it will click now. So it is like you know how to solve question, then try to solve in this particular frame. That is right. So make sure that you always solve question. Yeah. Now you can get done with the elevator problem. So what comes next? Yeah, you can say trolley problem. Imagine we have a trolley, and you throw some ball with respect to trolley. Maybe a ball. So now you're throwing it at in the vertical direction, okay, with velocity v, and the trolley itself is going forward with velocity vt at the time of projection. Now imagine if the trolley is accelerating with acceleration a. So now what will happen? The moment you throw, the ball will leave the trolley with two velocity, v trolley and v naught, which is with which you have thrown, and subsequently it will travel like this. Okay, that's one thing. But in the same time, when the ball is returning back to the trolley might have moved because of the acceleration. It might have moved somewhere here also. In fact, it will move like this. So the question is, when the ball will come back to the same level, how far it will be behind the trolley? So we have found the gap between the ball and the trolley. At the time, it will come back to the same level. ignoring the size of the trolley. No need
Sir,
to
I
think
didn't
about it.
understand the question.
Pardon?
Sir, I didn't understand the question.
Question is, when you throw the ball upward, what will happen? It will go up and come down.
Yes, but with our perspective, is that one?
Okay, yeah. So will it come up, go up and come down in the uh, what we say in the trolley frame? The answer is no. Why no? Because trolley is not moving with constant velocity; it's accelerating, so VT will change, but the VT of the ball will remain always VT, right? I hope you didn't get this answer. When you
Yes,
throw a ball,
yes,
this is the velocity of ball with respect to trolley. So it is not a ground frame value. So if you want to write in ground frame, VBT equals to VB minus VT. What is VBT? It's V not J cap. And what is VB? Okay, I'm trying to find actually. What is VT? It's VTI cap. So what is VB? V not J cap plus VTI cap. Or you can say the ball velocity is along horizontal also and along vertical also. So this is the situation in the beginning actually. This is the beginning value. The initial velocity of the ball. See the initial velocity of ball in the ground frame. Okay. So this is the initial velocity of the ball in the ground frame. So you know that ball is trying to go horizontal also and vertical also. So the ball will follow the parabolic path, isn't it? This is not a rocket science. I think this you can understand.
yes,
So you're throwing like this. So what is the actual path of the ball? It will be parabolic path. Now the question is, what will happen to trolley in the same time? So now the ball is traveling only VT with constant velocity VT horizontally, but the trolley is accelerating horizontally with a greater acceleration. Greater, so the trolley is accelerating, so its velocity will be greater than the VT after the start. It means in the same time, when the ball will come back to the level of the initial level, the trolley would have moved much more than what the ball will move. So the trolley must be somewhere ahead of time. So in
yes,
the same time, trolley will be somewhere here actually. You can just think like this. So the question is, what is the gap between the trolley and the you can say? Imagine it's thrown from the edge of the trolley. I mean, that's the idea. It's difficult for you to understand. So maybe I can do one thing. This is fine. All right. So I hope it is okay. This is fine. So now when the ball will come back to the same point, the trolley must be ahead of the ball, isn't it? The question: what is the gap between the ball and the trolley? So one way is to solve in the ground frame. Other way is you can directly write the answer. So x relative, because we know that the ball also have traveled some value, and the trolley has also traveled some value. So x trolley minus x ball, and this is x we are trying to find. Trolley has gone ahead, so we can in fact find the x relative directly. Why? because we can write as x relative, or in fact this is the delta x relative, is it's a very simple formula. It's a ux relative into t plus half ax relative into t square. Now this we are trying to find, which I'm calling as x. What is ux relative? Can you check the initial velocity of the trolley and the ball in the x direction? And is there any difference between the two?
No, sir.
No, this is zero. And look at the acceleration of the two in the so this is there is a difference, of course, a. So this is the only difference is there because ball cannot have acceleration horizontally, but the trolley will have, and that's my answer. So I got the answer x equals to half at square. And finding the t is very easy. So in fact, we know what is the time of flight. So it will just go up and come down, just like the vertical motion. So the time of flight is definitely 2 v naught by g. That's it. So what we're getting is 2 v naught square a by g square. Now this is the answer for the relative separation. Or if you want to solve in the ground form, even that's easier, not a big issue. Why it's easier? Because you can find the trolley displacement, find the ball displacement, and just subtract. So in ground frame, I mean, we can always solve, as I said. So x refers to x trolley minus x ball, and I mean this is so easy. What is x trolley? So Vt t plus half at square minus what is ball? Vtt. That's it. The range formula. So anyway, this is one line answer, half at square. And finding the time of flight is anyway, you know what is the answer. So yeah, it's again the same. So a relative is just a way to solve a question. It's not something which we are forced to solve. We can always solve in the frame which we are interested in. And if you are not comfortable, first try with the ground, keep the answer ready. And maybe while solving in the ground frame, you will realize that okay, what are the terms which are getting subtracted, and yeah, maybe one fine day you will get the hang of this method. But in the beginning, yeah, I mean, I can understand. It is going to be not so intuitive. So writing expression is always challenging. Okay, all right.
So that ux is the velocity, initial velocity of the trolley.
UX means initial velocity of the trolley and the ball. So what I'm doing is I am writing this. I'm subtracting the uh, what you can see x of trolley minus x of ball. So my sequence is t minus b. So I'm writing t minus b for everything. Okay. As I said sometime, like you always maintain the sequence. So delta x relative means x trolley minus x ball minus x not trolley minus x not ball. If you want to go so far, then ux trolley minus ux ball into t plus half ax trolley minus ax ball into t. So now, if you write completely, then there is no ambiguity. So you can just substitute the value, you will get the answer. Now, this is what we are looking for, and this is what we have called x, right? And this was zero. Why? Because they begin at the same point. Understood? So we took this as initial point for trolley
Yes.
and the ball. And this part we know it's again zero because both are same. And this part we know the ax ball is zero, ax trolley is a. So you can see the answer is x equals to half a minus zero p square, and that's over. And if you want to find for the whole time of flight, then just substitute small t equals to capital T. And capital T finding is very easy because trolley is not moving in vertical direction. So the capital T is just the way we can find generally the time of flight formula. So we know T equals to 2 u by g. That's it. So the expression which I wrote in the very beginning of called the relative kinematics. If you can write entire thing, then there is no ambiguity. Just write entire thing and substitute properly. You will get the right answer. But if you fail to, you know, substitute properly, you will have a okay some trouble. Okay, I hope this is clear to all of you.
Sir, I have to note that.
Done. Is it done?
No, sir, second.
So in a similar fashion, if I say that the trolley is
Sir, I just
retarding, so what happens if the trolley is retarding? So then the ball will be ahead of trolley because the velocity of the trolley will be always less than vt, but the ball will always remain vt. So you will travel less than what the ball will travel. So it will be behind, and the answer will be just negative, or the value will be half a r t square. So if it is retarding, I would have substituted a equals to axt equals to
minus
minus ar, and that will give you the negative answer, which means oh, you will be actually not ahead, you will be behind that side. So the mathematics will take care of itself. What you need to do is just maintain the order of substituting the values, and mostly see the first line which I write on the left hand side of the equal sign. You can see uh, uh, the point which I made here. Now this expression I normally do maintain. So I really do not bother to write this expression while solving question. So this is already imprinted in your mind, so you know what to write. So that's why it will reduce the effort of writing. But in the beginning, I will suggest that you write every term and then go ahead, because I think initially figuring it out that what to write may be a difficult job, or maybe you miss the plus or minus sign. Okay. So it's a good practice to go like this. And this is what I said, like the way you have been solving problems of kinematics will always give you the pain when you solve the difficult problems. And that's why the convention, the rule to write things is very important. Okay, these things are actually meant for uh, advanced learning process. So do not stick to the old method. Again, I'm saying, I mean, that's not very fruitful. Well, yeah, once you master it and then you can see the things clearly, there is no need to write anything in fact. So most of the questions you can do mentally, but that takes some time. Not much.
or
Okay,
why
tell me.
that ux t minus uxp becomes 0? So that
The what is the UX here of the ball? What is the UX of ball and UX of trolley? The initial velocity of trolley is this, and the ball is also the same.
So yeah,
there's
so sir, both will be means in initial it will be in the same
same.
speed, right?
Correct, correct, correct. So if the ball was on trolley, then it must have the velocity of the trolley all the time. So when you throw additionally with V naught, so that is with respect to trolley. So the VT is anyway there, and that is what we have proved here. So the velocity of ball is how much? In the ground frame, the velocity of ball is Vt I cap and V naught J cap. So Vt I cap, V naught J cap. This is the ball. Okay. No, rest up to you. Practice and realize. So we have done the two problems. Then okay, I mean, of course, we can keep on adding problems like this, but rest I'm leaving because I hope you got the fair idea how to proceed questions like this. So I will switch to a new variety of problem, which is two-dimensional problem. So I will say this as 2D collision, and it's really nice to begin with. So let's say we have a tower. This is the ground, and now so we have two balls. One is projected from the top of the tower, and other from the bottom of the tower. So that's the question. Now, what is given to us? The ball top of the tower is thrown horizontally, and the bottom is thrown at some angle, and the tower height is h, and it is thrown with speed v1. This is thrown with speed v2. Now, what is the actual path? Like actually, what you can see, and the actual path of this is and it is found that they actually collide at point P. So what we know is that they are colliding. Okay. Now the information which is given to you is that V1 is thrown horizontally and V2 is thrown at some random angle which is not shown actually, which you need to you may need to assume or may not be. I don't know. So the question is after what time they will collide, and if I choose this as x-axis, and if I call this as y-axis, so what is the x and y coordinate of this point? If particle 1 and 2 not if particle 1 and 2 collides at P, then find x, y. Okay, so this is the question. So every question of projectile requires time at which this event will occur. So now I'm not teaching you anything. What I'm saying is just you follow the guideline. When they will meet, their final position vectors will be same or different.
Sir, same.
Exactly. So now you know the position of the particle at the instant of collision, which is same, which you don't know, of course, but you know it's same. That's information. And initial position you can actually see in the picture. So I have drawn the x and y coordinate. Now what you are supposed to write is write the kinematical equation for position, the displacement one, the maybe the second one, and then just substitute the values which you can see in the diagram. You will automatically get the answer without any effort. So now the question is, can you apply that formula, the big formula, delta R formula, for relative motion of two particles? Can you apply?
Yeah.
Okay, so go ahead and try to apply the formula and see what happens. See how you get the time directly. So the formula will give you the answer directly without any thinking, much thinking. Now you may think so, the V2 angle is missing. You can choose the value of angle and then write the vector equation. You have to write the vector equation in I cap and J cap always. And at the end, you have to compare the coefficient on both sides with I cap and J cap, and you shall get the answer. Just go ahead and try this out.
Sir, in this question, sir, I did that. I took the components of V2 and V1, and then sir equated it on the point P, x is equal to y. Sorry, point P, sir. Sir, both will be have same position vector. So how we will find the x and y coordinate?
So you got the answer? No.
No, sir.
Okay. So what you are doing? Like what you're trying to solve? What you are trying to write the question? Can you tell me what you are doing actually? Did you use the formula delta equals to u vector t plus half a vector into
Yes, sir. This one.
Sir,
t?
not used. Sir.
So how you get? Are you like some doing magic or some you have become the PC Sarkar?
Sir, I tried with the component.
Don't try. See, no, don't try with anything. Try with what I'm saying first. So there are various ways to solve this question, but the first is try the most fundamental way of doing it. So just write the relative equation. So this is r minus r naught. First, you try to write these expressions. I mean, the first thing you haven't learned is how to write these things because that's not your nature. You are still not trying to learn. You're trying to apply the same routine stuff which you have been doing, and every time you're not getting an answer, but you're not learning. The problem is you're so stubborn that you're not trying to evolve. So that's called the rigidity of learning. Like you are stubborn in terms of learning, not as a nature. I'm saying it's a discipline. Like that's some attribute of yours. So when I teach something new, you need to practice something new to actually adapt to this new way of writing, learning. But that's not there. And then just you need to process, this entire expression. So when we have two particles, what we do? So we write one minus two. And this is the last time I'm showing it. Else, I mean, I will stop this chapter. I will not teach you at all because you guys don't deserve in that way. So this is I have taught you already many times. And now just simplify this expression. So every time when two projectiles will meet, this term will automatically become zero. So for any collision problem, the R1 will be equals to R2 because they are meeting at the same point in space. So the difference is always zero. That's obvious. And the rest you have to write in the I cap and J cap format. And I don't think it's so difficult. Now because both are projectiles, so I can say the both will free fall with accessing G. So even the last term is also zero. So now we are only with left with two terms, and you're supposed to just substitute the value there. Is it such a big deal? Because the last term is also zero. Because we know that here a1 equals to a2 equals to g. I mean, and so it will be again zero. If two terms are zero, then you will get the just two terms left. And what you need to do is substitute the value in I cap and j cap. See, you're not even able to substitute the value. That's the problem. So what you guys are learning is like you're mugging up some method and happy with that. I don't know what you're doing. So I can see U1 is uh, V1. What is U2? Now writing is
Sir, it's
difficult.
V2 cos theta.
Yeah, so you need to
I
assume some theta, then show. So V2 cos theta I cap plus V2 sin theta. So you just write like this. And what is the initial position of the first particle? You say it's Hj cap.
can H
What is the initial position of the second particle? It's nothing
Zero.
zero
because it's at the
null.
origin. So because we know everything, what is the next step? Just substitute and compare the coefficient of I cap and j cap on the both sides of equal sign. So we get the set of equations which you need to solve. So can you go ahead from here and solve and tell me the answer? What is time of flight? I mean, what is the sorry? What is the time after which it will collide? So this expression will give you t at which they will collide. Solve it and tell me the answer. Done.
Sir, X and Y will come in the form of V1, T, V2, consider like that.
Yes, yes.
Hello, sir.
Yes.
So I got the answer.
Your voice is not.
So that x is v1 minus v2 cos theta and y is v2 sin theta minus.
Yes.
Sir, I got answer as v1t minus v2 cos theta t as x, and y I got h minus v2 sin theta t.
First of all, tell me what is your theta? What is cos theta? What is sin theta?
Sir, cos, cos theta is that for the theta for the v2, which is going, so theta is that one. Sir, we have to express cos theta and sin theta in the form of y and x.
In terms of only h, v1, v2. So only three things are given to you: v1, v2, and h. So everything should be in terms of these three terms only. Nothing is else given. The rest is solving for you. Okay. Getting into this. So we can write as the first term is 0 as we have discussed. Okay. Maybe I'm writing the, let's say the A implies, okay. The first term is 0 minus, what is R not 1? The initial position is h j cap minus 0. Let's leave it. What is U1? V1 I cap. What is U2? V2 V2 sin theta j cap into T. Now, if you compare the x component, nothing is on the left side, so G. And if you compare the x component on the right side, it's V1 minus V2. No sequence. And if you compare the y component, it's minus h. And if you compare the y component, it's minus V2. It's done. The This is 0, which means V1 is V2 cos theta. So if you solve, the cos theta will be automatically 1 by 2. So we got the answer. And if you solve this expression, it is h plus 2 V2 sin theta, which you can tell is 1 minus cos square. So the t turns out to be h upon, and once you get the t value, so we know that the x coordinate will be nothing but the displacement of the first particle, because it has traveled x on this one, because you are thrown horizontally, so you can say this is x is nothing but the v1t also, or you can say v2 cos theta. So it's the same thing, v1t or v2 cos theta into t. So just individually we can solve. So v1 into h by under root of answer also. And the y component is again very easy, because it's a horizontal motion for the first particle, so it must have fallen through how much in the vertical direction? Half dt square. So this is half dt square. We all know this thing. So the y coordinate is h minus half dt square, or you can just write the formula for that. So, yes, done. Okay. So you have to just substitute t is explained. Okay, so now let's look at the answer and try to answer. Is it clear now?
Yes.
Did you realize how to solve? Understood? No. Okay.
Yes.
So you can always solve by the formula, or you can solve by the relative concept, or you can solve by the ground frame also. So we can see that because they are colliding, so they must have the same x coordinate finally and same y coordinate finally. So you can do it coordinate wise. So what is the x of v1, x of v2 after time t? So you can get that answer and equate it. Okay. So the idea is how you write the expression. I mean, do you really understand the kinematics, or you still think that a equals to half this square is the formula is that only, but you need to apply it in different direction, different approach, relative form, or absolute form, ground frame. Okay, so this all require practice. But these questions you can actually solve in a really faster method. I mean, mentally in one line. So, so what I said in the very beginning, if you remember that the time is invariant, which means we can always choose a suitable frame which can make this calculation really easy. So now that approach is something fascinating. Like, can we really find such method which can solve the question in oh, in one line? And the answer is yes. So today I'm going to introduce you something very new to your thinking process. So I'm looking for time calculation, right? So my interest is how to find the time after which they will collide. And what I'm saying is you can always choose a frame which makes the calculation easier. So what we can do? So we can do something like this, isn't it? We can do something. So the two particles will have same acceleration. So A1 or A2 both will have same acceleration, which is acceleration due to gravity. So the relative acceleration is zero. Now that is something interesting. If the relative acceleration is zero, what does it mean? If I choose one of the particle as my observer, then the expression for acceleration will never appear. Why? Because they have same acceleration always. So there is no question of relative acceleration. So one cannot see two as accelerating, two cannot see one as accelerating. So now what will happen if that is the case? If one cannot see two is accelerating and two cannot see one is accelerating. So how their path will be if that is the case? So imagine if I choose the bottom as my observer, or you can choose the top as an observer. So bottom will be at rest, right? Now what we do if you remember how we replace the velocity. So one will have two velocity, one right, another
Above.
other parallel to this line, isn't it? So other will be parallel to this line. Which line? V2. So the V2 will add up to V1, and now this will disappear. So imagine this is now not present. Imagine because two is observing and the H is this. Now they are colliding. So in the frame of two, how V1 must move to hit two? That's the simple question. What should be the path of V1 as seen by V2 such that it must hit the V2. What do you think? So it must be like this towards the observer. That's it. Because in that way only it can hit. There is no other way. So if the ball one will move in any other direction than this green line, it cannot hit the observer. But it is said in the question that they must hit. I mean, they're colliding, so they must be hitting like this. So now we have changed the entire perspective of solving the question. And you may think this as theta, or may think this as theta, up to you. So to move in this green direction, the component of velocity perpendicular to the green direction must be zero, which means the V2 will have two components, V2 cos theta and V2 sin theta. So V1 and V2 cos theta must be cancelling each other effect so that it can move directly here. So for collision, the first thing is that V1 must be cancelling the other effect of cos theta. And once you cancel it, and it's a constant velocity equation, the time taken to hit will be how much? It's pretty easy. And it's done. You can see from here we can get cos theta and we can substitute here and our answer is over. Now this approach is good for calculation of time, because as I said, time is invariant and it does not depend on any frame. So I can always choose a frame which can make the calculation easier for me. So now it's easy. We know that it will hit after this much time only. And why the acceleration is not affecting? Because the free fall is same for both of them. So one cannot see that change of other, because the height with which you have fallen down is same for one and two both, because gravity is acting on both of them. So whatever height you have fallen, it is always same for both. So you cannot see that movement. Okay. So we have the answer in one line.
So that V2 parallel to V2 is minus V2.
Pardon?
So that V2 the velocity which you took with the V1 in the southwest direction. Sir, it is
V12 is how much? Velocity of one with respect to is V1 minus V2. So V1 is already shown, and what is V2? So it's addition of minus V2. So V2 is like this. So what is the minus V2? So the minus V2 is a vector, but value is V2 only. The numerical value is how much? The numerically the magnitude is V2 only. So we have shown the vector arrow whose length is V2. V2 is the magnitude, and because we have shown with the proper direction, so we have added the vector in the reverse direction with the same magnitude. So why I should add V2 minus V2? So there is no need to add minus V2. Okay.
yes, sir.
Okay. So now there is a very interesting third method also. Now this is my method, which is much more proficient than the remaining method. And what it says that do not affect the motion of every particle, like do not make any of them as observer. Rather, let's bring some the third observer. Okay. So let's say I am the third observer trying to look at the event. Now, I always want to see the event which moves in a straight line. So what I don't want to see is the curve path or the parabolic path. So I'm only interested in looking at the event in which every particle is traversing a straight line. which means there should not be any the t square term in the expression, which means there should not be any relative acceleration, because when I make the a relative is 0, the half a t square vanishes, and so the equation will left with only ut term, which is a linear function of time. So our endeavor is to convert every expression into a linear function, and therefore I will become the third observer, and I will move with the exactly same acceleration as that of the each object. So at the time of projection, I am the G frame. It means I am the frame which itself is accelerating downward with acceleration G. And therefore, the moment I become the G frame, none of the particle will accelerate in my frame. Why? Because I'm also falling down with acceleration G. So the relative acceleration of each particle in my frame will be how much? 0. Understood? No. So acceleration of G frame is how much? So what is the acceleration of first particle with respect to G frame? A1 minus A G frame, and A1 is G, G frame is G, so it is 0. So what is the acceleration of the second particle in the G frame? So now the particles are not accelerating. So now the G frame is the fastest or the quickest method to solve any collision problem of projectiles. Now, okay, maybe one. So how this is the fastest method? If you realize that the first particle was thrown in which direction? Horizontally. And second was thrown at some angle. Now in G frame, they don't have acceleration. So how they'll move further? The motion will remain a straight line because none of them are accelerating, so they will move their straight line. So the only point where they can collide is this point. So if the first particle is moving with velocity v1, so after time t, if they are colliding, then how much this will be v1t. So how much is this line? V2. And now this makes a triangle whose angle we can see is it's a right angle triangle. So can we write directly the Pythagoras? The v2t square equals to, we get the answer t equals to h/. And again, why this answer must be true? Because time is invariant. So irrespective of the fact which frame I choose, my answer is going to be same. Is this clear?
Sir, please will you explain the t equals to h by v2 sin theta of the last method?
No. If you can understand by observation, try to understand, else you can leave this. Now, none of these methods are supposed to be part of the syllabus. So the very concept of time invariance, you guys have not understood. Time is a quantity which remains same in every frame. We are solving for collision. So in every frame, their path must meet at one point, and that point will be the point of collision, which means at the intersection of the path, the particle must reach at the same instant. Then only collision will occur. Now the shape of the path depends on frame. So in G frame, both particles will move with constant velocity because they don't have acceleration. And therefore, if you extend those paths, it will intersect somewhere called the point of intersection. And for collision to take place, both the particles must arrive at that point at the same instant to make the collision. The rest is the Pythagoras applied and solve it because V1T is the length, V2T is the length, H is the length. Is this clear? No.
Yes, sir.
Understood? Anybody?
Yes, sir. Understood.
Okay. So there's some basic notion of collision. For collision, the fundamental rule is if you take one of the two particles as an observer, listen very carefully what I'm saying. If you have two particle collision and if you choose any one of them as an observer, the first rule is the other particle must be approaching towards that observer. Then only collision can occur. Understood what I'm saying? May
Yes.
not. Okay, so how to deal with this part? Let me show you. So maybe this topic will help you out. So let's try to understand that if we have two random particles moving in two random directions with two random velocity, like two different velocities. Try to understand this concept. Alpha. I am ignoring the acceleration of each particle. Let's say they don't have acceleration. See, the biggest problem comes in solving question when two particles have different acceleration. So we cannot cancel both because if you try to choose one as the frame, other will have still have some acceleration. And in such case, we stick to the kinematical equation. So no frame will help you solve the question faster. So the real point of interest is those situations in which either they are not accelerating at all or they are accelerating with the same acceleration. So when they accelerate with same acceleration, then again there are two approach. One, take one of them as an observer, so they will lose acceleration. Or use the G frame, like not G frame, you can say like the frame which is having exactly same acceleration as that of the two particles. So again, for that third observer, acceleration will be gone and the path will become a straight line. So the entire set of problems we can divide into two categories, or in fact three categories. One, when particles do not accelerate, that's the first case. So that's very easy. Just it's a straight line, you can solve by the normal. No relative frame is even needed. But yeah, you can use it. The second is accelerating particles. So now we need to check that they have same acceleration or different acceleration. If they have different acceleration, then the only way to solve is use kinematical equation in a relative form, or you solve in the ground form. The choice is yours. If they have same acceleration, then of course the method is you can choose the ground form to solve. That's totally okay. Or you write the relative kinematics, or you choose a frame in which their acceleration vanishes, or you choose one of them as a frame. So these are options which you need to create kind of some sort of algorithm in your brain. So you need to design the algorithm, these patterns. Now it's difficult to explicitly mention all and everything in notes. There are certain things which remains between you and me only. Okay. So this is something which we share with those students who learn from us. I cannot make it public. So this algorithm is very important. You need to understand the algorithm, like how like a brain of teacher is working behind these questions. Sometimes I, as a teacher, expect that the student will figure it out with so many numbers, and sometimes you guys force teacher to give it explicitly. Okay, anyway. So today I gave you explicitly, which generally I expect that you will figure it out, because once you figure it out, these things, it will remain with you forever. It is stay with every student forever. Okay, so sometimes these things are important. So when we solve question on a this board or Zoom board, the answer is not important. When any teacher is solving question, do not look for the answer. Look for the how he is approaching the problem, and there comes the learning, and then you can raise question there. So why you apply this method only? Why not other method? So if you ask me the right question, then I'll be really happy to answer this question, because that will show that okay, you are really stuck with the concept, not with the question. So generally, what happens, like most of the students, they try to mug up variety of answers. They see the solution of various problem and think that this will help them in mastering the subject, which is not the case. I mean, if you're learning physics, chemistry, or mathematics, you should have the maximum focus on derivation part, or what I'm saying in between those lines. So listening is also a very important skill. If you listen properly, you will realize that I'm saying everything you need to solve any question of kinematics, and for that matter physics. Nothing goes beyond my theory in JE domain. So for every question, there is some algorithm which you need to realize, you need to understand. These are called like some sort of like, see, you can always find the pattern why I'm doing this. So why I'm choosing variety of frames. What is my motto? What is my purpose? So the purpose is, I think, pretty simple, to make the calculation easier, isn't it? Am I doing something wrong with the choice of different frame? Is the frame selection the only way to go? Can we solve question in the ground frame as well?
Yes.
So these are the questions which you need to ask yourself. Why you're learning this method? How it is going to help you? Okay. So no, maybe this theory will help you a lot, which I am expecting. So we have two parts, this one and two. Okay. So let's take one of them as an observer. Now you tell me which one you want to take an observer, one or two.
One.
One. So let's call this off. So the moment you take one as an observer, what will you do next? The velocity of one, the acceleration of one will be assigned to whom? To in which direction? So the moment you make one as an observer, then one cannot have velocity. So what is the speed of one with respect to one?
Sir, 0.
Yeah, of course zero. You cannot have velocity in your own frame. That's impossible. Like you're saying that my car is running ahead of my car. So the moment one becomes observer, one cannot have velocity, one cannot have access, and one cannot have anything. So one will become rest. So now the moment you make one as an observer, one will be like a particle at rest. It's not moving now. Is it rest? But now two will have two velocity. Its own velocity which it owns, and one gifted by the observer, because now the observer is at rest, so it gives everything to other. So V1 will be, of course, we know how to add V2. I mean, you have to take a, what do you do? You add the velocity in
Solve
the
the
reverse direction. Now, numerically, the length of the arrow remains how much? It is V1 only. Value, what I'm writing is
same.
here the value, it's not vector. Vector I have shown, and what I'm writing is the speed, the value. And what is this angle? Beta. What is this angle?
Alpha.
Alpha. Now the resultant of two vectors will be somewhere in between. So the resultant can be like this. It may be here also. It may be here also. So in which case it will collide? If the resultant is like this, the V2 and V1 will be moving like this. So will it hit the observer one? The answer is no. If V2 and V1 is having this resultant, what will happen? Will it hit the observer one? No.
No.
So to hit the observer one, what is the only way? That the resultant must be along this direction. That is the idea, right? The idea of collision is simple. The resultant vector of V2 and V1 must be along the line joining the particles. Now, how to make sure that this will happen? Now, that is maybe the question that you should have asked. So, how to make sure that that will happen? So, it is easy. We know that for that to happen, so we can resolve the velocity into components. We can say V2 will have component V2 cos beta along the line joining the particles 1 and 2, V1 cos alpha along the line joining the particles 1 and 2. And so the net velocity along the line joining the particle 1 and 2 is V1 cos alpha plus V2 cos beta. So any component which is perpendicular to that line must be zero effectively. It means for collision purpose, what we do? We draw a line which is perpendicular to the line joining the particles. That's the first thumb rule. So if you do not want the collision, then the only way is that V2 sine beta, which is trying to take you up this way, and V1 sine alpha, which is trying to take you down, they must balance. And if this component will cancel each other, then it will have no choice but to move this way. Okay. But I'm not taking that case actually. So I'm taking a general case. So let's say the resultant velocity is this way. So what I can say, this is the velocity called velocity of 2 with respect to 1. Now, do you realize this v2? Understood?
What's no?
This you understood?
Yes, sir.
Wait,
So what is v2? Velocity of 2 with respect to 1.
with respect to
Sir, the
Now,
V1 is observing V2.
yes, v1 is the observer. So now what we can realize that if it is not colliding, so it must be passing on a, it must be moving on a line. So what is the minimum separation between the two objects? The how close these objects can be? How close 1 and 2 can be? So they can be only closest when it is passing through the foot of the perpendicular. Understood? If you draw a perpendicular from 1 to this line, so the minimum distance between a point and the line is the foot of the perpendicular, which means the instant 2 is here, these two particles are closest, and this is called the distance of closest approach. We say d minimum. You can see it's written there. So what is d minimum? Distance of closest approach. And for collision, we can say d minimum must be, for collision to occur, what is the value of d minimum? For collision to occur, what is the value of d minimum? Come on, guys, say something. Totally muted, eh? For collision to occur, what should be the value of d minimum? Are you guys not able to hear me?
so that
Seems that like you guys are totally lost now, not able to digest anything more than that. I mean, you have come to the end of your limitation of learning. Is my voice audible first of all?
Yes, sir.
so yes,
Can you answer the question which I'm asking?
yes.
So let's say D minimum is the minimum gap between the particle 1 and 2. So my question was, for collision, if they are colliding, what will happen to D minimum?
Sir, it will go to 0.
Exactly. So this is what I'm asking now. So why you took so much time to answer this question?
Sir, I
I
came
thought you
now.
were the asking the value of data.
No, I'm not asking the value. I'm asking the, yeah, of course, value. So the D minimum will approach to 0, isn't it? Yeah. So at the time of collision, the D minimum is 0 for sure. Okay. Okay. So can we find the D minimum from the, okay. So let's say if we denote the position vector, so this arrow represents position vector of 2 with respect to 1. So what this line will represent? R12, right?
R1.
Yeah. So this arrow, we call it R1. Can we see this angle as theta? So that's just for some time. Now R12 is the distance. I mean R12. If you take the mod of R12, you can say that is the distance between 1 and 2. So can you find the D minimum in terms of theta and R12? I think so. We can find. And if you look carefully, it's very easy. So can we write a D minimum is mod of R12 sine theta. Now you can check this.
Yes, sir.
Okay. So D minimum is R12 mod sine theta. So I can do one small thing. I can multiply by V21 in the numerator and divide it here, because that will make no difference, right? So this is fine. And if you look
Yes.
carefully, the numerator is nothing but the mod of cross product of R12 cross V21 upon. Now this is the vector form of writing the D minimum. Is this clear?
Yes.
Yes, sir.
Okay. Now we are also interested in the time after which their separation is minimum. So time after the start when their separation is minimum. Time after the start when their separation is minimum. So when the separation is minimum, when you go from 2 to 2 dash, right? So the particle number 2 has gone from where to where? 2 to 2 dash. So time is how much? Distance from 2 to 2 dash, which is nothing but the R12 cos theta upon time. I mean, sorry, upon speed, which is V2. So the time is R12 cos theta upon V2. Do you realize this first of all?
Yes, sir.
So now you can multiply with V21 again in the numerator.
Scalar product.
This becomes square. And now the numerator is a very simple thing called R12 dot V21. It's a dot product. So this is the vector expression to solve the question. Now the question is, will you be able to remember these expressions? Answer is no. So how we can remember this answer? So unless you don't know how to draw this diagram, you cannot solve this question. So what you should actually practice is drawing the diagram, practicing and realizing the stuff. And always try to derive the things from drawing the proper diagram. And if you master this diagram, these things are secondary. This is like nothing. It will never affect. But if you don't do
Yes.
that, it's a challenge. So if you think that I will try to remember this, it's a wrong thinking. What I'm suggesting, remember this diagram. How to go from there to the answer is the thing which you need to learn, not the formula. Because no one remembers the formula after 2 years. And you're not writing, KBC Karopati that you will remember today and today will answer and okay, it's fine. So for JE preparation, the approach which can let you remember things for longer duration, only that will matter. And only those students, those who learned with the basic fundamentally, they are very sound. Only they remember the entire syllabus at once, because syllabus is going to be huge. You can understand that your entire physics of class 10th, just imagine how much was the syllabus of class 10th. I think
Sir, very less.
much more less than the kinematics. If you add all pages of kinematics, it may exceed your class 10 syllabus. Maybe. If you add vectors, it may exceed also. And now we are done with just 2 chapters. Like in fact, we have not completely the two chapters. So imagine the syllabus of 25 chapters of physics and equal number of syllabus of mathematics and chemistry. In fact, more than that. What do you think? Will you be able to mug up everything before the examination?
No.
The answer is no. And that is why I'm always saying that the approach by which you guys might have got some marks, maybe 99 or 100 or maybe 200, those things really doesn't matter for JE preparation. So JE preparation having no correlation with someone getting any marks. I have a student who go over able to only get 70% marks in boards, and they got very nice rank in JE, maybe like around 1200 or 1300. And those with 98.8 in ICC board, he failed the JE mains also. The problem was his approach was always wrong, but he never realized and he stick to his own method because that worked for him in class 10. And so he thought, okay, no, it will work for me also in class 12. And he was definitely wrong. So why I'm saying this, because some of you might be still wrong in your thinking process. I'm just trying to rectify it. So don't take your, what you did in class 10th. It has no correlation. What you do in class 10th actually matters nothing, because in class 10th I got 60%, 61%. Most of my friends got 70%, maybe. The topper was, topper got 78%. And my state topper was my friend only. And I have taught all of them, 78 percentile rank, because they had a very good handwriting. My handwriting was extremely poor at that time. So I cannot get marks because of my handwriting and other reasons. Are like I don't never liked other subjects, so I was only into physics and chemistry and maths. So my marks never affect my ability. So you may be not liking some subject, you may not be getting marks in that subject, but that is not your ability. Your ability is to learn something fundamental. And if you develop that ability, I can assure you, for you, JE is going to be just like a piece of cake. JE is actually nothing. It's only hype. And the 90% problem that why students are not able to crack it, the only problem is the bad class 10th experience. They're still not able to come out of that, the percentage, euphoria. I got 98, I got 99. Those are garbage actually. Those are just simply garbage. You can throw anywhere. So if you're able to adapt to new way of learning, welcome to JE. Else your struggle will never end. And don't try to be hurry up. Don't try to become master of physics in one day. Physics takes time to master it. It is the most easiest and the most difficult chapter, also you can say subject. You can always hear the stories of physics. If it clicks to someone, it's easiest. If it never clicks, it is always the most like a nightmare for everyone. And physics is very important. I'm saying why. Even if you go into the industry, those who are very good with physics, you will see that many physicists has taken the role of the CTO of a company. They are technical chief technical officers because their ability to solve problem and visualize problem is so powerful that they apply into the different domain and they bring out something very interesting to the company. So if you go to the IBM headquarters, which is in Detroit, US, of course, you will not go today. So I have friends there, and they say that the topmost position of any software company is not occupied with computer programmers. Oh, sorry, they are not when doing any coding also. So they are mostly physicists who knows quantum physics, who knows something more than that. They have done PhD in physics, and they are the pass out of Harvard and Stanford mostly. So even IBM knows that to solve a new problem, they need physicists or some good quality mathematician, not this computer programmers, because anyone can code, not a big deal. It's just a language. You just need to convert into language. So physics gives the perspective to visualize things first of all. When I draw some diagrams, the purpose is so that I can show you how the thought processes I'm trying to convert into some visual picture, and from there I try to solve the question. So like these diagrams which I have drawn here is your ability, not the formula. So what will differentiate you from the rest of the student? If someone can draw and derive, and someone who can just remember. So if a teacher will ask you what is the dividend, and he will blurt out this answer quickly. So he may be a very nice student in front of that teacher. And what you will say, no, I don't remember the formula, but I can derive from here. Okay, welcome to IIT. You are the right candidate to be part of IIT. So you're not supposed to remember things. This is a garbage. I say this is a garbage. Garbage. All is garbage. This is the thing. And no one looks for this thing. So even I think you guys are looking here, here, here. So try to eliminate the garbage of learning. These all formulas are garbage. I mean, I don't need these formulas. I can show you many garbage in my today's lecture. Do you want to see the garbage? See, see how many garbage. This entire page is garbage. Why? Because I have already taught you the entire concept of a relative expression. So you should know that how to write some which formula. Maybe I have it in the next page. Yeah, this formula. This is the real concept. Everything else is garbage on this, not my this page actually. Okay. So what is next garbage? I can show you. This entire page is garbage because I have already explained that this is the thing which I need to remember. Everything else is garbage here. And you can say, okay, this is the thing which you need to understand. The rest is garbage. So this is garbage. Here again, everything is garbage except this, which you already done. Again, this is something new. So you can learn here and then again you can apply, and the rest is garbage. So in this entire 6 phase, which we have discussed so far, the thing which one should learn is just one or two lines, and rest is called garbage in physics. Now, if you try to occupy your brain with garbages, you will be always bothered about remembering things. But if you just realize the concept, like what I need to fine tune my brain with so that I can derive these things, then you will realize that okay, your brain is at much ease and you can actually attempt any problem because you know how to approach. So formulas are really not the thing like one any physicist should look for. I never tried to see formula. Now, of course, because of so many years of teaching, I happen to remember these things naturally. I mean, but I have never put an effort to remember since my childhood when I was like you only. So you will ask me a question, I will derive from basic and I will tell you the answer. I don't remember anything. Okay, anyway. So you guys have good memory, I know, but don't misuse your memory. In fact, I have seen that this generation is very good with remembering things. That's also one skill, but don't waste that skill for the storing garbage. Okay. Is the time over? Like, what is the class time for today?
Sir, 2 o'clock.
2 o'clock.
Yes, sir.
All right, then we have some time. Yeah, we will continue. Okay, fine. So when we can apply this concept? Okay, so there is a very a standard problem in kinematics, the distance of closed approach. So let's say we have two mutually perpendicular roads. I hope you all have understood what is the garbage and what is the concept, right?
Yes, sir.
So don't try to store garbage in your brain. Your brain is really nice. Use it for the good purpose. try to minimize the information which you should store, try to figure it out that what I should store so that I can rederive whenever I want from scratch. And that way if you proceed, then you can say the physics notes is only of 10 pages or maybe 20 pages. Else your physics notes will be roughly of, I can tell you, around 900 to 1000 pages, else 20 pages. So up to you how much garbage you want to store. So we have two mutually perpendicular roads. So that's a nice thing. So basically it's a road actually. So let me show you as a road. Maybe, and these roads are okay, of course intersecting. Okay, you can see how we create them. So now we have two, like a road as you can see, and we have two cars. So let me bring some cars. The first car is on this axis. This is the origin I'm saying, so that you can do it mathematically. And the other car is here. So in the beginning, the first car is at a distance of L1 from the intersection, and the second car is L2 from the intersection. The speed with which both the cars are moving, we call it V1 is the velocity of the first car and V2 is the second car. And what we are supposed to solve is that what is the closest approach between these two particles. So of course you can use the vector formula which I have given you, and then I will show you how we can solve it organically from the scratch. So you can take your time and solve this question. First, you can use the formula. You need to just express everything into vector form. And once you express things in vector format, you know you can get the answer for sure. So that's like a mechanical process. And then I'll show you what is the organic way of solving this. Okay. So try once and then I will help you out. Don't worry, I say a lot of things, not to mean anything wrong to you. It's like I know the possible mistake every student commits in their learning process. So just listen to me what I'm saying. Whether I'm saying rudely or politely, it doesn't matter. Listen to my words only. It will help you out. So are you trying this question?
Yes, sir.
Okay, go ahead.
Hello, sir. Hello, sir.
Yeah, tell me, tell me.
Sir, Thurva Samant is in the waiting room.
Okay, okay, okay. Accept.
Sir, I got E equals
Huh.
to under root V2 square L1 square plus V1 square L2 square divided by V1 square plus V2 square.
No, the square, the root term will not come in the numerator because in the cross product it is never root.
Sorry, sir, I forgot to that. I had put the root in the downwards, but by mistake I had put forward. So it should be minus V2 L1 minus V1 L2 divided by V1 square plus V2 square.
So this is the time you are saying time.
Yeah, sir.
So time cannot be negative, na? So that's still wrong. So the answer was mod of uh, R12 cross V1, I say R1 dot V12 upon V12 whole square. R12 dot V21 upon V21 mod whole square, right?
Yeah, sir.
The time is mod of R12 dot V21 upon, and it's easy to solve because R12 is what? R1 dot, what is V21? V2 minus V1? V2 minus V1 mod. So you just need to substitute the value. What is R1? Minus L1 I cap.
minus L1.
What is R2? Minus L2 J cap, just below the origin. And then take the big dot. V2 is V2 J cap spin up. V1 is V1 I cap spin up. And so V2 J cap V1 I cap mod square. So the answer is simple. Q is L2 J. I mean, you take J and I with I. So minus L1 minus V1, so it's L1 V1. And plus L2 and plus V2, so it's L2. So the answer is simple. It's just dot product. And the mod will become square, and if you square this term, will become without the root sign. So this is the answer. Is this your answer?
Sir, I got the upfront of the
I should
down.
not-
Yeah, sir. Sir, means I didn't do the mod, that's why I got minus.
No, no. If, okay, even if you don't do the mod, it will be plus one because minus L1 I cap dot minus V1 I cap will become L1 V1 only, right? So it is not because of mod I'm getting plus. It is plus.
Sir, I got that numerator part right, but
So can you find the minimum separation between them?
Yes,
The
sir.
only difference from minimum separation, you have to remove the dot with cross and then solve it properly. Take the cross product of these terms. You will get the easy answer. So what happened to the D minimum part?
So last lecture.
No.
Sir, I got that calculation wrong. So that's
Pardon?
I by mistakenly put the wrong value in the denominator part. So that's why I got the
Okay.
denominator.
Okay. Okay. No problem. So do this problem. So this is only practice. I mean, don't worry about in the beginning. What happens? Like why I say so many things, because I need to change your entire perspective. I mean, you guys are in a different mindset which needs to be changed as soon as possible. So this is like a transition phase for every student. When they come from 10th class to 11th class, there are many things which is wrong. So we need to correct it, rectify it at least. So don't worry. I mean, just proceed. You will get everything correct sooner than later. So once you get the answer D minimum, you can use the vector formula, get the answer. I will try to put into the organic method, like how one can approach again from the basics. Now, which basic? The basic is this one. Like the way I did it here for the random things. Now I have someone has given me this beautiful diagram. Let's say this is a given to you, and then now I want to proceed in the same fashion. So can you think of this method here? That is something interesting. You may take 1 hour also. I mean, I'm happy. You can just ping me after 1 hour so that I got the answer. But if you can get it in 1 hour, that is your achievement of lifetime, or maybe 2 hours, maybe 4 hours. Like it really doesn't matter, because every second you spend here will teach you much more you can imagine. Normally, students feel that okay, if a problem is taking 10 minutes, 20 minutes, leave it. In kinematics, you should not leave anything, because in kinematics we have very limited equations or formulae, and from there the answer must come. So it's like you have to just do the manipulation till you get the answer. Do whatever it takes. Okay. So
Sir,
anyone who is interested in solving this question from the scratch without using any formula? Yes. Tell me, Harshit.
sir, so that D minimum, uh,
Hmm.
so that after that we got the D minimum, the value.
Hmm.
So in that last diagram, which you said as that we have to remember
So yeah,
always the
same V1 and
This
then
is yeah. It's the L2 V1 minus L1 V2 or vice versa. And because we don't know which one is bigger, so the difference of the two upon under root of V1 square plus V2 square is the answer. Because in the D minimum formula, the formula is R12 cross V21 mod upon V2.
sir.
Yeah.
Sir, in uh, the last slide,
Mm-hmm.
so that diagram, so that diagram shows that the D minimum will be
Mm-hmm.
at the point at that two dash. Uh,
Correct.
sir, so the path is the above diagram, right?
The path is a green line. In the frame of observer 1, the 2 will move in this green direction, green arrow. Because I have taken that as V21, right? So V21 means what? Velocity of 2 as seen by 1. So in the frame of 1, the 2 seems to be moving in the direction of green arrow, and which is nothing but the resultant of 2 and 1.
Yeah, sir.
Yeah.
Sir, so the D minimum should be very close to the point from where they started.
See, I will tell you something. If we have a point, if we have a line, what is the minimum separation between the two?
The perpendicular to the line.
The perpendicular. So if the green line is the path of the second particle and one is the point a dot, so what is the minimum separation of the 2 points? The perpendicular. which means
Okay.
when the particle number 2 is crossing this point, then the separation is minimum between the particles in this particular frame. Now, again, this is a very interesting part. Is the value of D minimum depending on the frame? Is D minimum variant or invariant?
So
Think about it.
invariant.
Yes, it is invariant. And because it's invariant, so it really doesn't matter which frame you choose. So that's why I have solved this question in which frame? In the frame of 1. So when you find the location of individual particle, it depends on the frame. But trying to find the difference of the position of the two particles, it is always independent of frame. So the idea is D minimum is the separation between the particle, and no matter which frame you choose, you must get the same answer. So we try to solve it in a frame which is giving me the simple answer. So I chose the frame 1 as the frame of reference. You could have done the same for taking 2 as the observer and one is moving in some other direction. And one will have some random direction. So one will have something like maybe this, it may be moving this way. In that case, you will draw a particle like this, and this is the minimum separation. So it depends on which question you're solving. So as you change the frame, things will appear very differently from the first case, but all will lead to the same answer. So it really doesn't matter which frame you choose. Okay, it really doesn't matter. Now you should try from scratch by drawing a simple diagram. You can draw just like lines like this. And what you need to do is, you know that one particle is here, two is here. I'm giving you some hint. So I'm going to take two as the observer. Let's say I'm taking this time two as the observer out of no reason. So one will have two velocity, right? Its own velocity, and now one is down. So the resultant of these two will be something like this. Just assume, and then draw a perpendicular from here. So this is the minimum separation. Now this is what we did actually. This is that. Okay,
Yeah, sir. Now
and
understood.
now you can do it. So try doing it from here also, like because here also you need something. Okay, it requires some manipulation. You can get the answer. Take your time. I'm here today, man. Of course, I will not end the lecture till for next 20 minutes at least. And with this problem, we complete one variety of problem of distance of closest approach and collision. And after this, we have three typical problems, like which are a very standard problem of physics, relative kinematics, that we can finish in 1 to 2 lecture maximum. So by next week, the kinematics will be totally over. And we have finished it really fast in 1 month by taking extra lectures because it's a really huge chapter. So kinematics takes actually a lot of time. And now we will be starting the laws of motion very soon.
Sir,
Yes.
sir, done.
Sir, done.
Very good. So what you did to solve this question?
Sir, just I recreated the diagram. I said
So
now
you're not
if
supposed to
you
use vector, right? You're not supposed to use vector. So I'll show you how to do this. So first of all, this angle is that's called theta. And this angle we can find easily because we know that tan theta is v2 by v1 because it's the velocity, right? Now this length I don't know. So I will say it y. But this length I know, it's 1, L1. So I can also write this is y by L1. And this gives me the idea how to get y. So y becomes v2 L1 by v1. It's the first step. And once you get this step, then you can find this length easily because this is L2 minus y, right? So the entire thing was L. And if this is theta, so this is also theta. Because this is 90 theta. And now I got the answer. D minimum is L2 minus y cos theta. Done. And because the first term will give me cos theta also. Because tan theta is v2 by v1, so cos theta is how much? v1 by under root of the square answer. So L2 minus y, which is v2 L1 by v1 in bracket into v1 upon under root of, and I'm done. Is this what you did? And I'll put a mod because I don't know which one is bigger because, okay, actually I have no idea numerically which one is bigger. So that's not the value. Okay, so this is the organic way of solving the problem. And of course, many more things like this you will also explore on your own and while in the tutorial also. Okay, so let me end the lecture here and very definite, kind of problems are there called the rain man problem, the river boat problem, and the wind plane problem. So these three variety of problem, which is a part of SC Verma, will do in the next lecture. Okay. I'm sharing the PDF for the last lecture and the lecture in a while.
Thank you, sir.
Okay, bye.